Hello everyone, my name is Ziming.
My name is Yiqian. We are presenting our paper, Exploring Intended Functions of Indoor Flying Robots Interacting with Humans in Proximity. Flying robots, widespread in various applications, have been extensively studied in the research field and gained significant attention in the commercial landscape. However, these studies often overlook the nuances between indoor and outdoor use, the distinctions in design factors, noise levels, and functional needs between indoor and outdoor drones are substantial, leading to different interaction possibilities and challenges. Surprisingly, previous research, though inspiring, has a blind spot when it comes to focusing on indoor applications. This leaves a research gap that we aim to fill by exploring indoor human-drone interaction. Proxemics, the study of how humans utilize space during interactions, is crucial in understanding indoor drone applications. Studies have shown a link between drone proximity and user discomfort, influenced by factors like sound, appearance, and cultural differences. However, research investigating how to convey the intended functions or roles of drones is currently missing. We believe it is necessary to integrate an indoor drone into a wider context of use, which means that users will have clear expectations of the function or role of the robots. Therefore, we chose to apprise participants that the drone they encounter in the experiment had a specific purpose, aiming to support users' understanding and bridge the existing research gap.
Our study employed a within-subjects approach with two factors: distance conditions, near, far, and function conditions, camera, education, pet, unknown, resulting in a total of 8 conditions. Concrete scenarios were constructed for each function. Prototyping utilized a Crazyfly 2.1 drone with meticulously designed flying trajectories and movements. Participants were immersed in scenarios with home decorations and furniture to simulate a cozy environment. Camera scenario: the drone autonomously captured photos and videos, adjusting its position for the best angle. Education scenario: participants were asked to first solve a trigonometric question, then program the drone to fly circles based on the solution. Afterwards, the drone eventually took off and flew circles. Pet scenario: participants interacted with the drone as a robotic pet, petting it gently before it took off, and then performed a little dance involving rotations and jumps. Unknown scenario: participants were told the drone's purpose would remain undisclosed. It performed a sequence combining movements from other scenarios. 60 participants, fluent English, were involved in the laboratory-based experiment in Luxembourg, a small European country situated between Belgium, France, and Germany. Detailed procedures were explained, and consent was obtained. Each participant experienced all 8 demonstrations presented in a randomized order. Following each demonstration, they filled in a questionnaire. After all demonstrations, participants underwent a semi-structured interview. The questionnaire consists of 6 items of semantic differentials on a 7-point scale, addressing aspects such as noise, usefulness, pleasantness, stress, attractiveness, and safety. Ratings were reversed for certain measures for statistical analysis. Semi-structured interviews, conducted in English, explored participants' preferences, experiences, feelings about the drone, and suggestions for additional functions or design improvements. We visualized the original data of ratings using stack bar charts to illustrate the distribution of participants' responses. Non-parametric analysis were conducted using aligned rank transform, ART, for our factorial design with repeated measures. Where there was no significant main effect of distance on perceived usefulness, statistical analysis revealed significant main effects of both distance and function on all other measures. Post hoc analysis revealed differences in these measures between distances and functions. Although no significant interactions between function and distance were found for all measures, the interaction plot hinted at possible interactions. We acknowledge this as a limitation of non-parametric analysis. Overall, the results suggest that both distance and function play important roles in shaping participants' perceptions of indoor drones. Concerning the distance factor, except for usefulness, all other measures receive better ratings for far compared to near. Regarding the function factor, education was notably rated better than the other functions, while unknown was rated the worst. Surprisingly, in terms of the comparison between the camera and pet, the perceived noisiness was almost identical. However, they varied significantly across the other 5 measures. This indicates that perceived noise is not a decisive element in perceptions of drones.
From the qualitative results, we observed that participants overwhelmingly found the drone demonstrations to be engaging and effective for learning. The hands-on experience allowed them to grasp abstract concepts and apply them to real-world scenarios. Moreover, programming the drone sparked a sense of achievement among our participants. They expressed pride in successfully achieving their design outcomes. Furthermore, the study led to the acquisition of new insights, understanding, and feedback. They suggested enhancements such as safety features and visual aids to enhance the learning experience. Interestingly, familiarity with using drones as camera influenced participants' preferences, with some expressing a preference for their adaptability and unique features. However, it is essential to address the concerns raised by some participants. Many expressed discomfort with drones flying around during social gathering, citing annoyance and disturbance. Safety concerns were also prevalent, especially regarding potential collisions and privacy invasion. Many participants use terms like cute, comforting, and cool to characterize the pet drone. Some saw advantages to having a pet drone as an alternative to traditional pets, citing its low maintenance. However, it is essential to acknowledge the diverse range of opinions. Some consider it useless, expressing discomfort with its role as a pet. Most participants believe that the pet drone differs significantly from a real pet, primarily due to its lack of emotional bond and inanimate nature. As one participant stated, "Pets are living things. I cannot have feelings with robots." The unknown demonstration was disliked by most participants. Participants highlighted the importance of clear communication and trust in drone operations. When they didn't know the operator or the purpose of the drone's activities, it often led to feelings of stress and discomfort. Privacy concerns also play a significant role, particularly during unknown drone demonstrations. Participants expressed worry about physical harm and potential civilian, emphasizing the importance of obtaining consent before recording or image capture.
Quantitative and qualitative results were reviewed and compared, showing resonance and complementarity. Measures of perceived usefulness and pleasantness close aligned with interview results, where terms like useful, useless, and pleasant, annoying were commonly used by participants. We created a scatter plot of post-ART rank means between perceived usefulness and pleasantness to visualize findings. Participants found the camera useful but annoying, expressed concerns about their privacy after encountering the camera drone. They considered the pet drone more as a toy and found it pleasant but useless. The education emerged as the most favored function, but most negative experiences was reported when the drone function was unknown.
The results showed that unknown functions received the poorest rating, leading to participant disapproval. To address this, clear communication is crucial. We suggest explicit methods like loudspeaker announcements or name tags. Alternatively, design cues can indirectly convey functions, like a party hat for camera drones or fluffy fur for pet drones. We also explore what makes an ideal flying robot. The education function was highly praised for its practical usefulness and emotional appeal. Nevertheless, concerns were raised regarding drone noises and safety risks. To address this, we recommend improving noise levels and enhancing safety measures. Achieving the ideal indoor flying robots involves balancing practical functionality with emotional satisfaction. Moreover, participants found the camera function to be highly useful, yet annoying and stressful due to privacy concerns. They also expressed discomfort in unknown conditions, suspecting surveillance. This aligns with Europe's heightened sensitivity to privacy matters, as indicated by references to GDPR. Therefore, the privacy risk associated with drone data collections and the potential misuse of collected data must be addressed. Additionally, participants found the pet drone cute and amusing, but useless. Interestingly, they saw it more as a toy than a pet. This challenges the idea that people would prefer using drones as pets. However, intriguing questions were raised about the boundary between living animals and machines. As AI advanced, could drones become so lifelike that they blur this line? This leads us to consider big questions about the future role of robots. Could drones replace humans in certain roles, like camera drone replacing photographers or educational drone replacing teachers? And what ethical questions would arise?
Future research could explore potential enhancements for education, camera and pet drone applications, as well as a broader spectrum of functions for indoor drones to expand upon our existing findings. This could involve investigating specific drone use cases tailored to diverse contexts and audiences, including different demographic groups and indoor drone environments like households, classrooms, malls, and offices. Additionally, considering that our study only involved a single drone, future research could explore interactions with drone swarms in real-world social settings. In closing, we wanted to share that participants mentioned a YouTube video titled Slaughterbots, featuring tiny drones using AI for assassination indoors, which had influenced their perceptions of drones as military weapons. However, participants acknowledged the transformative impact of our experiment as it's changed their perspective, highlighting drones' potential for positive uses. As researchers and engineers, we advocate for the responsible development and use of drone technology for the greater good. Thank you for tuning in. For more details, please check our paper.